Okay, to finish off this particular lecture, we're going to look at some operations of radicals and rational exponents, and then kind of start putting all this together, everything that we've learned in this particular section. We're going to go ahead and put it all together with variables and everything else included. So if we look back, at problems that we've worked in the past, we've things like terms. So we have 2x plus 5x, and since those are like terms, it's equal to 5x. And then, of course, we extended that idea to saying, hey, you know what? If we have a radical that's the same, this radical would be considered like term also. And so that would be 5 square roots of 2. So we can take this process a little bit farther as well. If the rational exponent is the same, then it has like terms. And if it's, again, a radical with the same root, then they're like terms. And so if we're looking at this in part A, that's understood 1 in front of there. And so they both have the fourth root of 2 as a common term. And then we would just simply take 1 plus the 3 to get the 4, and then the fourth root of 2 would be the carried term that would be common. So this idea of like terms is important for you to understand, but also your ability to recognize when you're dealing with like terms. So if you look at part B, it looks like you're dealing with a whole bunch of numbers there that you're probably thinking of a million different operations that you could try to do. But really, you need to recognize first and foremost that the two parts that are being multiplied to the 7 and 2 are actually the same. And so we can simply add the 7 and the 2 together to get 9 and carry the common expression with the rational exponent that's the same. So 6 to the 1/5 in this case is actually identified as a common terms or like terms. Now, if you remember, we had some problems with square roots where the terms weren't common, but we had a situation where we could break one of them apart to create common terms, and that's what we're going to do here. We're going to take the cube root of 16 and we're going to break it apart so that we can create a situation that has common terms. And of course we have the cube root of 2 for both parts now. And when we take the 2 minus 1, we have 1 times the cube root of 2. And of course the 1 is understood, so we would not have to write it there. So these are some basic operations that you could see with either rational exponents or radicals, and so you need to be comfortable with combining like terms and identifying like terms. So if we look at sample problem number 3, you could go ahead and pause the video real quick and work that problem. Okay, so now we have a situation here where the cube root of 81 and the cube root of 3 are not like terms. So we need to break the cube root of 81 apart so that we can come up with the like terms. And so, of course, that's an understood 1 there. So 81, when you divide it by 3, gives you 27. So we're going to break 81 up into 27 times 3. And, of course, we have to keep the cube root with both of those. And then the cube root of 27 is actually 3, so that gives me 3 times the cube root of 3. Now be very careful here, and I'll make this a little bit more noticeable. This 3 is separate of the cube root of 3. We don't want to make it look like 3 to the 3rd power. That would be a mistake that we don't want to make. So if you need to give yourself a little spacing between your roots and the number, the coefficient that goes in front of it, you need to do that. And now we have a situation where we have like terms, the cube root of 3 on both parts, and so I can take 3 minus 1, which is going to be 2, and then of course times the cube root of 3. And so we want to just write that far enough apart to where it doesn't look like 2 to the 3rd power. So that would be incorrect. Okay, so those are some basic operations that you're going to deal with radical properties. Now we're going to move into a situation where we're going to combine everything that we've learned in this set of notes together, but we're going to do it in a situation where we have variables. So now this is a place where our calculator is not necessarily going to help us. So what I want you to do, I've spaced my set of notes a little differently than what you probably have on your set of notes, just so that I'll give myself plenty of room to work. If you need to do that, feel free to give yourself as much space as you can. These problems can become very lengthy, and this is a situation where you want to be able to spread your work out as much as you possibly can, so that it's easier to see and that you're not getting different parts confused. So, take lots of liberty with your space here as you work these problems. Now, what I'm going to ask you to do, there's 6 samples here. We've got A through F that you're going to be working. I want you to do your best to go ahead and pause the video now and work these problems the best you can. If you want to do them one at a time and then come back and see the solution, or if you want to work all 6 and then watch all 6 solutions, whichever way you want to do it. But refer back to previous parts in the notes to help you out as you go through this. So go ahead and pause the video at this point and work in whatever order that you feel will help you. Okay, what I'm going to do is I'm going to actually go ahead and work each of these problems, and I'll just take a little pause between them so that you can stop the video if you need to. But we're going to look at sample part A. We have the cube root of 125y to the 6. Now, what I want to do, just like I did in previous examples with square root, so if I have a square root problem here, let's say 25x squared, I really want to deal with the number and the variable separately. So I can take the square root of 25 and the square root of x squared at different parts. So that way when I come back here, I deal with them individually and then I'll put them back together. So that's really what I'm going to do with part A. So I'm going to start off by breaking this up. I'm going to get the cubed root of 125 and then the cubed root of y to the 6. Now, cubed root y to the 6, we can go a little bit farther and we'll get to that in just a second, but let's just deal with the cubed root of 125 first. We're fortunate in this regard that we don't have to break the 125 apart because the cubed root of 125 is actually 5. Now, the cubed root of y to the 6. Remember that powers and roots that are the same can be eliminated. Whenever you see a power that is bigger than the root, what that tells you is that there's a root in there, there's a power in there that will eliminate with the root, and we just need to be able to find it. And so in this particular case, I'm going to break the y up to a little bit smaller pieces, and of course I want it to be able to cancel out with my root. And so in this case, I'm going to have y to the 3rd, and then if I take y to the 6 and I break it up and I have y to the 3rd, then what I technically have left over is y to the 3rd again. So in that case, in the first one, the root and the power cancel, and the root and the power cancel in the second one. So I have this situation where I have 5 times y times y. Now remember, this is y to the 1st and y to the 1st, and so I want to combine those back together again, and so I get 5y squared. Now if we would have looked at this part to begin with, we could have seen that I had 6 and 3. There was enough to cover 2 roots of 3. So if you recognize that that just reduces down to y squared, that's really good. But if you didn't, you can break it apart into simpler terms as well. Okay, so that's our first one. First look at simplifying radicals with a variable in it. Alright, now I'm going to go on to part B. Now part B gives us a rational exponent, and of course the 1/2 exponent is outside the parentheses, so the first thing I need to do is I need to distribute that to everything in the parentheses. Now the big mistake that a lot of students make is they forget about the 9. Do not forget about the 9. So 9 to the 1/2 power. U squared to the 1/2 power. And v to the 10th to the 1/2 power. So that's basically what we're doing here. Now, in this particular case, we're multiplying. Remember, anything raised to the 1/2 power is the same thing as taking the square root of it. So 9 to the 1/2 power is actually 3. Whenever we take a power of a power, we need to multiply these. So 2 times 1/2 is u to the first, and keep in mind all this is being multiplied together, and then 10 times 1/2 is actually 5, so that's v to the 5th, and of course I can squeeze all this back together again and write it as 3u v to the 5th as my final answer. Okay, and so that's using properties of exponents with a rational exponent. Alright, let's go to part C now. Alright, part C, we have a root here, and we have a fraction under the radical, so we can't have a fraction under the radical. So the first thing I have to do is I actually have to break these apart. Now if we look at the top one, we can see very comfortably that that 4th root and that power of 4 cancel each other out. So that's going to simply just leave me x on top. However, on bottom I have a 4th root and a power of 8, and so I can see that I have more of a power than I have a root, so I can break that up even farther. So I can say that's y to the 4th, and then the 4th root of the leftover, which is y to the 4th, and when I do that, I end up getting both of them canceling out. So I'm left with y and a y, and of course I need to bring those y's back together, and if you recall, that's an understood 1, so that's y, 1 plus 1, which is y squared. Okay, so that's another look at a situation where we have a power of 8 and a root of 4, and we actually had twice as many, so it would have been y squared. And you'll start to recognize those situations with more practice. Okay, now we get to part D. Now part D is an extremely challenging problem, and what I'm going to recommend to you, if you probably already worked this, is that you have a number, an A, a B, and a C. So you have 4 different parts underneath this radical. What I'm going to suggest to you is to separate all these different parts, deal with them as if they were individual problems, and then when you're finished, combine back together all of the different parts. So let me show you what that looks like. So if I take the 5th root of 5, and then of course I have the 5th root of a to the 5th, and then I have the 5th root of b to the 9th, and then the 5th root of c to the 13th. You can already start to see that spreading these problems out, there are going to be some very large problems. So what I'm going to suggest to you is this. Take each of these as if they were their own separate problem. And then when we get down here to the bottom, we can come back and combine together the parts that need to be combined together. So if we look at the 5th root of 5, there's really nothing I can do there. That's as far as I can go. And so when we come back, we're going to still have the 5th root of 5 as part of our final answer. Now, we look at the a, the fifth root of a to the fifth, the 5's cancel each other out, simply leaving us an a. And don't forget, all this is still being multiplied together. Now, the fifth root of b to the ninth, notice, again, we have more of a power in here than we have a root. But this time we don't have a situation where it's exactly twice as much. So this is a situation where we're going to be able to take out 1/5 of it, but we're going to have some remaining b parts left under the radical. So we're going to break this up. I'm going to have 5 fifth root b to the fifth, but that's going to leave me the fifth root b to the fourth. Now if I were working this farther, that cancels out, leaving me simply a b, but there's not enough b's left over underneath the radical to cancel out with the fifth root. So this is a situation where I just have to leave those 4 b parts underneath the fifth root as it is. And so I'm just going to stop right there with the b's. Now I'm going to go deal with the c terms, and you can see again, fifth root, power of 13. There's a lot of c's underneath there. So I'm going to start off by taking out 5 of them, and then that leaves me with 8 more. So I can take out 5 more, and of course that leaves me with 3 more. What you've got to recognize is that each of these powers, the 5, and the 3, all should add up to that 13. Now, in the first two, the power 5 and the root cancel out, leaving me c times c. But on the third one, we can see that I don't have enough c's underneath the radical to cancel out with the 5, so I have to leave this under the radical. Now, this is where breaking it up and working them all as individual problems makes it a little easier, but then at the end, it can become a little bit confusing. So what we have to do here is we have to find all of the parts that are no longer inside the radical. So I have an a, b, and 2 c's that are no longer inside the radical. So I have a times b, and then of course that's c squared. Then I also need to find all of the parts that are still underneath the radical, and I need to combine those back together. And so I have the fifth root of 5, b to the fourth, and c to the third, and that should all fit underneath the radical. Now, this is all being multiplied together, but be careful here. If you wrote your c squared too close to the fifth root, you could get some funny looking answers. It could look like it was c to the 25th power or something of that nature, and we don't want that to happen. So this is actually our final simplified form of that. And so that is a very complicated problem, and you can see that these things can get drawn out pretty complex. Okay, let's go to our last 2 samples. You can see in part E, we're dealing with an operation with radicals, but hopefully you recognize that the square root of y is a like term. So I can just add the 5 and the 6 to give me 11 times the square root of y, and that is our final answer. And then lastly, again, we have like terms, and of course it's not always easy to recognize that xy to the 1/3 power and xy to the 1/3 power are the same in each, and so we're going to take the 2 and we're going to subtract the 7, which is going to leave us -5, and of course we have to carry our like terms. Okay, and so that finishes up the operations of exponents and rational exponents and radicals. You definitely need to get lots of practice, especially on some of these longer, more drawn out problems. They can be very confusing and complicated if you don't break them into their simpler parts.